Okay, let's dive in. It's June 6th, 2025. And looking at the sources you sent over, wow, there's some intense and really varied weather happening across the globe right now.
It really is striking, isn't it? You've got this major severe weather outbreak hitting the central U.S. We're talking tornadoes, widespread heavy rain impacting tens of millions.
Yeah, I saw.
And then you flip over to South Africa and they've just had heavy rain, but now they're getting severe winter weather warnings, even snow warnings happening at the same time.
It's quite a contrast. So our goal today really is to take this snapshot of today's, global weather and use these reports to understand it better, not just as random events, but how they fit into the bigger picture of climate change. What are the sources saying about the patterns, the drivers, the connections?
Well, what's really interesting in these documents is how they frame it. They acknowledge natural cycles, of course, like we're in an ENSO neutral phase right now, so no strong El Nino or La Nina influence.
Okay.
But they emphasize these extremes are happening against what they call this intensifying background signal of anthropogenic climate change.
So even without a big natural driver like El Nino pushing things, the underlying warming is already making a difference to what we see today. Is that the idea?
That's exactly what these reports are arguing, and they've got the data. They point out 2024 was, in fact, the warmest year on record,
Right.
reaching 1.55 degrees Celsius above the pre-industrial average.
Wow.
And what's more, the projections included, they show an 86% chance that at least one of the next 5 years, so 2025 through 2029, will temporarily go over that critical 1.5 degree warming threshold.
86% chance for 1 year.
And, maybe even more significantly, a 70% chance that the average temperature over that entire 5-year period will itself cross 1.5 degrees.
Okay, so the average could cross the line we're trying to avoid permanently. That's going to soon. How do these reports link that level of warming back to, say, the specific things happening today, like the intense U.S. rain or that sudden cold in South Africa?
They highlight a couple of key things. One is the intensification of the hydrological cycle. Basically, a warmer atmosphere holds more moisture.
Right.
So when it does rain, you get heavier downpours like we're seeing. But it also means more evaporation from land, which can make dry periods worse elsewhere.
So it drives both extremes. Floods and droughts, sometimes simultaneously in different places.
Exactly. These reports paint that picture clearly. Floods here, while other areas like maybe the Canadian prairies or parts of Europe mentioned are dealing with persistent dryness.
That feast or famine pattern? What about the oceans? I know that's always a factor.
A major one, according to this material. Warmer oceans, higher sea surface temperatures, which are a clear climate change signal, they basically provide more energy, more fuel for storm systems.
Okay.
So the early tropical activity they're watching off Mexico, or the forecasts for an active Atlantic hurricane season, the sources present that as fitting this pattern, potentially stronger storms.
Right. So, okay, we understand the big picture drivers. How do the reports connect this to, real world impacts? Like, what about agriculture? How is today's weather hitting farmers?
Yeah, agriculture is flagged as really vulnerable. Today's specific weather is causing immediate problems. You've got heavy rain slowing down the maize harvest in South Africa, for instance, and it's delaying planting in parts of the U.S. Midwest. But then conversely, you have that dryness threatening crops on the Canadian prairies.
And I saw something in there, too, about the timing of rain affecting the wheat harvest on the U.S. plains.
Yes, timing is absolutely critical. And the reports also bring up this interesting concept they call thirst waves.
Thirst waves?
Yeah, it's not just about lack of rain. It's about consecutive days with high evaporative demand driven by heat, wind, low humidity that can just suck moisture out of the soil really fast. Big impact on yields.
It sounds intense.
It is. And it underscores agriculture's sensitivity. The sources also note that, despite this vulnerability, the sector often doesn't get the climate finance it actually needs.
Okay, so let's try and wrap this up. Looking at all this material, today's dynamic, sometimes extreme weather. What's the main takeaway when viewed through this climate lens?
I think the core message is that these significant weather events we're seeing today, they aren't just random. They're happening on a planet that's, warming at an accelerating rate.
Yeah.
You see it in the record temperatures like 2024 and these projections saying we're likely going to breach that 1.5 degree threshold really soon, maybe even as a 5-year average.
And that warming, according to the reports, is intensifying the water cycle, fueling bigger storms and putting serious pressure on sectors like farming.
Precisely. The reports really stress that these kinds of intense, sometimes simultaneous events are becoming more frequent. And you see responses like the push for early warnings for all systems.
Right, trying to adapt.
Yes, but the material also points out there's still a big gap in actually getting those systems fully implemented everywhere they're needed.
So, considering these trends, these projections, the snapshot of today, what does this deep dive really tell us about the kind of world we need to be, well, actively getting ready for, starting now?